November 4th, 1943, 0630 hours, Mimoyecques, northern France. Oberingenieur Wolfgang Pilz studied the fractured steel barrel through morning mist. The V-3 Vergeltungswaffe, Hitler's promised London gun, lay twisted and smoking after its 14th catastrophic test failure. 500 meters of precision-engineered death, designed to shell London from 165 kilometers away. The Führer had demanded operational status by Christmas. Engineering reality demanded the impossible. In 3 hours, Pilz would brief General Major Dornberger on why Germany's most ambitious artillery project was killing more German engineers than Allied soldiers. The monster gun that would win the war was destroying itself, and everyone who dared to fire it. Don't forget to subscribe to World War II Untold Stories and like the video for your support. Thank you for subscribing. The V-3 Hochdruckpumpe represented the absolute pinnacle of German artillery engineering desperation. While Allied forces consolidated their Normandy foothold in late 1943, German weapons development had entered what military historians would later term technological panic phase, a period where strategic necessity overruled engineering feasibility. The Vergeltungswaffe program, initiated under direct Führer directive in early 1943, promised 3 revolutionary weapons systems: the V-1 flying bomb, the V-2 ballistic missile, and the V-3 supergun. Of these 3 technological gambles, the V-3 would prove the most catastrophic failure in military engineering history. Oberingenieur Wolfgang Pilz, a veteran artillery designer from the Krupp Works, had been assigned to the Mimoyecques facility in February 1943 with explicit orders to make the impossible merely improbable. The technical specifications demanded by High Command defied every principle of metallurgical engineering Pilz had learned during 23 years of weapons development. The V-3 would stretch 500 meters through chalk cliffs overlooking the English Channel, longer than 4 city blocks laid end to end. Multiple powder charges would accelerate a 140-kilogram projectile to over 1,500 meters per second. The barrel pressure would exceed anything attempted in artillery history by a factor of 3. The engineering team assembled at Mimoyecques represented Germany's finest artillery minds, men who had designed the legendary 80 mm gun, the fearsome Nebelwerfer rocket system, and the massive railway guns that had terrorized Allied positions from Norway to Gibraltar. Hauptmann Heinrich Schubert, the project's ballistics specialist, possessed a doctorate in metallurgy from the Technical University of Berlin. Oberfeldwebel Klaus Richter supervised barrel construction with 28 years of precision manufacturing experience. Major Wilhelm Kessler coordinated testing protocols with the methodical precision that had made German engineering famous worldwide. Yet from the program's inception, fundamental physics opposed their efforts. The multi-stage charge system, designed to accelerate projectiles through sequential powder detonations along the barrel's length, created pressures that exceeded the tensile strength of any steel alloy available to German industry. Each test firing generated tremendous heat and stress that warped barrel segments, ruptured charge chambers, and sent explosive debris throughout the testing facility. Military metallurgists calculated that successful operation would require steel alloys with properties that would not be developed until decades after the war. The strategic situation driving the V-3 program grew more desperate throughout 1943. General Heinz Guderian's intelligence assessments indicated that Allied bomber formations were systematically destroying German industrial capacity. Strategic bombing raids had reduced aircraft production by 43% since January. Tank production had fallen by 37%, despite increased slave labor deployment. Artillery production maintained adequate levels only through the cannibalization of captured equipment and the recycling of damaged weapons systems. High Command recognized that conventional artillery could no longer reach strategic Allied targets. The English Channel created an impassable tactical barrier for traditional weapons systems. German artillery doctrine, perfected through centuries of continental warfare, proved inadequate for cross-channel strategic bombardment. The V-3 represented the only theoretical solution to this tactical impossibility, a weapon system capable of delivering sustained artillery fire against London from fortified positions within the Atlantic Wall. The Mimoyecques installation required unprecedented engineering resources. Organization Taut deployed 14,000 workers to excavate the chalk cliffs and construct the underground firing chambers. Concrete fortifications consumed 210,000 cubic meters of material, enough to build 50 Tiger tank bunkers. Steel requirements exceeded the monthly production of 3 major foundries. The project diverted engineering resources from defensive positions, tank production, and aircraft manufacturing at the precise moment when German forces faced mounting pressure on multiple fronts. Pilz understood the engineering impossibility from his first examination of the technical specifications. According to his post-war testimony to Allied interrogators, he immediately recognized that the multi-stage acceleration system would generate barrel pressures exceeding 12,000 atmospheres, more than double the tolerance of the strongest steel available to German industry. The sequential charge detonations would create harmonic vibrations that would fracture barrel segments regardless of metallurgical composition. Heat generation would exceed cooling capacity, causing thermal warping that would destroy accuracy within minutes of sustained firing. The initial test program commenced in April 1943 with a 1/4 scale prototype constructed at the Hillersleben Proving Ground. Even this reduced model demonstrated the fundamental flaws in the acceleration system. The first test firing destroyed the prototype completely, sending barrel fragments over 300 meters. Schubert's metallurgical analysis revealed stress fractures throughout the remaining components, indicating that the multi-stage system created destructive resonance patterns that no engineering modification could eliminate. Yet political pressure from Reichsführer Heinrich Himmler and Armaments Minister Albert Speer demanded continued development despite obvious technical failures. The propaganda value of the London gun had become integral to maintaining civilian morale as Allied bombing intensified. Party officials promised the German people that Vergeltungswaffe systems would reverse the strategic situation and bring the Allies to negotiated settlement. Technical reality could not be permitted to interfere with political necessity. By September 1943, 14 full-scale test firings had resulted in complete system failures. Each attempt generated spectacular destruction, filling the testing facility with twisted steel and concrete debris. The longest successful firing lasted 17 seconds before catastrophic barrel failure sent a 200-kilogram fragment through the facility's observation bunker. 3 engineers died instantly. 7 more suffered severe injuries from explosive decompression and steel fragmentation. Major Kessler's testing reports documented the systematic failure of every engineering solution attempted. Strengthened barrel construction simply shifted failure points to different segments. Modified charge compositions reduced pressure, but eliminated the velocity necessary for cross-channel range. Cooling systems proved inadequate for the heat generated by sequential detonations. Computer analysis, conducted using captured British calculating machines, indicated that successful operation would require technological advances at least 50 years in the future. The human cost of the V-3 program extended beyond the immediate casualties from test failures. According to organization taut records, 127 construction workers died during tunnel excavation due to cave-ins, gas explosions, and construction accidents. Medical facilities reported 394 cases of silicosis from chalk dust exposure. Allied bombing raids against the Mimoyecques complex killed 68 workers and destroyed months of construction progress. The strategic resources diverted to the V-3 program could have produced 847 additional Tiger tanks or 2,300 Sturmgeschütz assault guns. Intelligence assessments from General Reinhard Gehlen's Foreign Armies East revealed that Soviet forces had developed their own supergun program based on captured German technical documents. The Red Army's artillery specialists recognized the same fundamental engineering problems that plagued the V-3, but pursued development anyway, hoping that improved metallurgy might solve the pressure tolerance issues. Soviet testing facilities near Leningrad conducted their own series of catastrophic failures throughout 1944, losing an estimated 200 engineers and technicians to explosion and structural collapse. The final V-3 test firing occurred on November 4, 1943, under direct observation from Berlin. Pilz had modified the charge sequence and reduced projectile weight in a desperate attempt to achieve even minimal operational capability. The test lasted 4 minutes and 37 seconds, the longest successful firing in the program's history. The projectile achieved a range of 43 kilometers, far short of the 165-kilometer requirement, but sufficient to demonstrate theoretical potential. Then the barrel exploded. The final charge detonation ruptured 3 sequential segments, sending a shock wave through the facility that shattered windows 12 kilometers away. The observation bunker's reinforced concrete cracked. The projectile disintegrated in flight, raining steel fragments across the French countryside. Emergency response teams required 18 hours to clear debris from the firing chamber. The structural damage rendered the facility unusable for future testing. Pilz's assessment report, submitted to General Dornberger on November 5th, documented the comprehensive failure of German military engineering's most ambitious project. The metallurgical requirements exceeded available technology by decades. The construction costs had consumed resources equivalent to building an entire Panzer division. The strategic timeline demanded operational capability months before engineering solutions could be developed. Military necessity had collided with physical law, and physics had won decisively. General Dornberger's response to the V-3 failure demonstrated the strategic paralysis affecting German high command by late 1943. According to his post-war memoirs, Dornberger recognized that conventional weapons development could no longer provide the tactical advantages necessary for German strategic success. The V-3's failure represented more than an engineering setback. It symbolized the collapse of German technological superiority that had dominated the war's early phases. The immediate aftermath of the V-3 program's termination revealed the cascading effects of technological desperation on German military planning. Resources diverted to Vergeltungswaffe development had delayed critical defensive preparations along the Atlantic Wall. Engineering personnel assigned to supergun construction were no longer available for conventional weapons improvement. The metallurgical research conducted for the V-3 program yielded no applicable innovations for existing artillery systems. Allied intelligence services, monitoring German weapons development through signals intercepts and resistance networks, recognized the V-3's strategic significance long before its failure became apparent. British scientific intelligence, under R.V. Jones's direction, had calculated the engineering impossibility of multi-stage acceleration systems as early as March 1943. American weapons specialists reached identical conclusions through independent analysis of captured technical documents. The strategic implications extended beyond immediate tactical considerations. German technological desperation indicated that conventional military solutions were no longer adequate for Axis strategic objectives. The Vergeltungswaffe program represented acknowledgement that German industry could not match Allied production capacity through traditional means. Technological innovation had become the only theoretical path to military victory, and even that path was proving impassable. Organization Todt began demolition of the Mimoyecques facility in December 1943, using explosive charges to collapse the tunnels and destroy the firing chambers. The concrete bunkers required shaped charges normally reserved for anti-fortification operations. The steel components were recycled for conventional weapons production, though metallurgical analysis revealed stress damage that reduced their military value by approximately 60%. The entire installation, representing 18 months of construction and engineering work, vanished beneath tons of rubble in a matter of hours. The psychological impact on German weapons development proved equally destructive. Engineering confidence, built through decades of technical superiority, collapsed under the weight of repeated technological failures. Research priorities shifted toward defensive systems and simplified designs that offered greater probability of successful deployment. Innovation gave way to desperate improvisation as material shortages and production pressures eliminated the luxury of theoretical development. Personnel reassignments scattered the V-3 engineering team across multiple weapons projects throughout the remaining war years. Pilz was transferred to conventional artillery improvement, where his metallurgical expertise contributed to incremental upgrades in existing systems. Schubert joined the jet engine development program, applying his pressure dynamics knowledge to more feasible technological challenges. Kessler received assignment to Atlantic Wall fortification design, where his testing experience informed defensive construction standards. Yet the V-3's failure also accelerated German development of technologies that would prove more strategically significant. Resources previously allocated to supergun development were redirected toward rocket programs that would eventually produce the V-2 ballistic missile. Metallurgical research conducted for pressure-resistant barrels informed armor development for late-war tank designs. Engineering lessons learned from catastrophic failures shaped more conservative development approaches that yielded practical weapons systems. The legacy of the V-3 Vergeltungswaffe extends far beyond its immediate military failure to encompass fundamental questions about technological innovation under strategic pressure. Military engineering, constrained by physical laws and material limitations, cannot transcend reality regardless of political necessity. Strategic desperation may demand impossible solutions, but engineering success requires adherence to scientific principles that acknowledge technological limitations. Modern military analysis recognizes the V-3 program as a classic example of technological tunnel vision, the pursuit of revolutionary solutions when incremental improvements would provide greater strategic value. American artillery development during the same period focused on production efficiency and reliability rather than theoretical breakthroughs, yielding weapon systems that proved far more effective than German technological experiments. Soviet artillery doctrine emphasized tactical flexibility and battlefield adaptability, creating systems that influenced military thinking for decades after the war. The engineering principles that doomed the V-3 remain relevant to contemporary weapons development. Multi-stage acceleration systems continue to challenge military engineers, though modern materials science has made limited progress toward solving fundamental pressure tolerance problems. Computer modeling can predict system failures more accurately than 1940s engineering, but cannot eliminate the physical laws that constrain technological innovation. Strategic requirements must still align with engineering feasibility to produce effective military systems. For military families who understand the relationship between technological innovation and battlefield success, the V-3 story illustrates how engineering excellence requires both vision and practical wisdom. German engineers possessed extraordinary technical skills and innovative thinking, but strategic pressure forced them to pursue impossible objectives with predictable results. American and Allied engineers achieved victory through methodical development of proven technologies rather than revolutionary breakthroughs that exceeded available capabilities. The men who died testing the V-3 system deserve recognition for their engineering courage and technical dedication, even as their project represented strategic misconception. Military service includes the obligation to attempt impossible missions when commanded, regardless of personal assessment of success probability. Their sacrifice contributed to the broader lesson that military victory requires not just courage and innovation, but strategic wisdom that aligns technological ambition with engineering reality. If you enjoyed this military history from World War II, don't forget to like this video and subscribe to World War II Untold Stories for more strategic analysis and personal accounts from history's greatest conflict. Thank you for watching.